Okay, so in this video, we're going to focus on experimental designs. Particularly, we're going to move from your understanding of the t-test, which I hope has sent some alarm bells off, and we're going to introduce ANOVA. Okay, think of ANOVA as the extension of a t-test. Again, try not to think that you're learning all these different things, right? Just to try and help with any potential anxiety or any problems. Let's try and think of, we're just expanding on what you already know. So you've already looked at t-tests. Now we're going to just introduce the, remember, concept of ANOVA. So in year one, you learned about t-tests, which helped us compare the means of two groups, okay? Using the standard deviation, I should say, of course. But what if you want to compare more than two groups? If you remember, with a t-test, we can test, I don't know, if we had a 100-meter sprint between a bunch of zebras or zebrae, I don't even know what the plural is, zebra, probably zebra, isn't it? And horses, right? If you wanted to compare the 100-meter sprint times, why you'd want to do that is another question. But if you did want to do that, you'd want to find the mean of each group, right? So what, out of 10 horses, what was the mean, the average 100-meter sprint time, and for zebra. And the t-test allows you to tell whether there is that difference between the means, if there is any, is significant or not. But it only allows us to ever measure two groups, right? So if we wanted to measure zebra, I've said that like the American terminology for a zebra. Zebra, not zebra, zebra, right? Horses and unicorns, okay? Then we can't use t-test, or we'd have to use 3 t-tests, and more on that in a few weeks. But this is where ANOVA, or analysis of variance, which it's short for, comes in, right? This is why we use ANOVA. ANOVA, this is key concept time, right? Allows us to compare multiple groups at the same time to see if there's a significant difference between them. So we could ask a much more sensible question of, is there a difference in exam performance between students who study for 1 hour, 3 hours, and 5 hours, right? Before, we were limited to just between 1 and 3 hours. But with ANOVA, you can add multiple of these and do it at the same time. So this is key concept number 1. ANOVA allows us to compare multiple groups at the same time. So as I said, ANOVA stands for analysis of variance, a method used to compare the means of 3 or more groups. It helps determine if the differences between group means are statistically significant. So the key point, ANOVA tests the overall distance between the groups, but it actually doesn't tell you which groups differ from each other. It just says, hey, there's a difference between the groups, okay? And that's it, right? We have to do something called post hoc, so post means after, so after the fact tests to find out where those differences are, okay? So if we compare study times for the 1 hour, 3 hour, and 5 hour conditions in this experiment, ANOVA can tell us if there's a significant difference in exam performance, but not between which specific groups, okay? We'll get on to how we determine that in later sessions, but for now, all I want you to think about is, okay, ANOVA, I can test more than 2 conditions, so 3 or more, okay? And it says, hey, there's a difference. And then we have to do something else in order to determine where that difference is. So this is when we can start to talk about factorial designs and ANOVA. So I have an unusual amount of cup of teas a day. It's what gets me through. So factorial designs allow us to explore the effects of multiple independent variables at the same time. So this is where ANOVA and factorial designs meet, right? This idea of multiple conditions. So in a factorial design, we can test the main effects of each variable and the interaction between them. What does that mean? Well, imagine if we wanted to extend our study to something more complex and to capture more information around the world. So we could change our research question. This is, by the way, this is what you'll be doing in your sessions. This is what you'll be doing for your project, pretty much. Is you'll ask something like, well, does study time 1, 3, or 5 hours per week or day, and caffeine intake, whether you take caffeine or not, influence exam performance? And again, ANOVA to the rescue. ANOVA can be used to test not only the effect of each variable, on study time or caffeine, but also whether study time and caffeine intake actually interact to produce some surprising results. Okay. So if we were to like sort of like draw out, this is what I always did when I was a student, like what that study would look like. You could make a little chart like this, where we have 6 conditions in total, right? We have 3 conditions for study time, right? Okay, it's gone through the green screen. We've got 1 hour, 3 hours, and 5 hours, right? And for caffeine intake, we have 2 conditions, yes or no. So we have 1 hour study time, yes to caffeine. 3 hours study, yes to caffeine. 5 hours study, yes to caffeine. Then we have another 3 different combinations, which are 1 hour study, no caffeine. 3 hours study, no caffeine. And 5 hours study, no caffeine, okay? And these would be the 6 conditions that we would create in our experiment. This is factorial design. So, while ANOVA helps us compare differences between groups, so here it's important to point out that we're looking for differences, right? So when we look at these conditions, we are asking ourselves, let me just see if I can get a pointer on the screen here. We're asking, say, okay, is this condition here different to this condition? Okay, is the same? Is this condition here also different to this condition? Okay. Then this is a little bit. Don't worry if we're not there yet with this. I'm just going to drop it in like some sort of like stats bomb. Let me just get rid of the. Oh my god, no, not that. Okay. get rid of the entire text. Right. What we can also do with ANOVA, we can say, well, are all the caffeine conditions, right? So all of these conditions, right? Are they different in general to all of these conditions? So does just taking caffeine matter? Okay, so we can do stuff like this with ANOVA. I don't want to go too far into it, but the point here is that we're looking for difference. Okay, we're looking to see whether there's a difference between conditions, and that's what ANOVA and its extension, how it's extended from the t-test can tell us. Okay, so again, while ANOVA can tell us about differences between groups, correlation and regressions can help us explore relationships between variables. So correlation, if you remember from last year, measures the strength and direction of a relationship between variables. So we could ask, is there a relationship between hours of sleep and stress levels? Is it the less time that you sleep result in higher stress, for example? A regression, however, and this is the extension, again, key concept time, we're going to go into regression in much more detail, is, I just want to plant that idea, okay? Is a regression allows us to predict the value of one variable based on another. It allows us to see the relationship between the two. So we can change that question slightly to be, can we predict exam performance based on hours of study, right? And we'll go through regression, we'll go through correlation much more in depth, but those are the general ideas. It's looking for the relationship between 2 or more variables. So simple regression, a simple linear regression, I should say, genuinely need theta function, try to think of it as like sort of extending the correlation. A correlation shows the strength and direction, so a positive or negative relationship between 2 variables. However, correlation only tells us that the variables are related, not how one variable can be used to predict another. Okay, that's where it stops. This is where regression comes in. So simple regression allows us to predict one variable, the dependent variable, based on another variable, which we call the independent variable. So again, can we predict exam performance based on the number of hours studied? Okay, that's what we'd use regression for. Now, again, can you see how we've changed the question here? Can we predict exam performance based on the number of hours studied? Yeah, this is different to those tests of difference that we looked at before. So here the research question was, is there a difference in exam performance between students who study for 1, 3 or 5 hours? Now, depending on what you're interested in, you'll choose a different type of design, okay? So simple regression, we can put in a little path diagram like this, where we could say, well, okay, how can number of hours spent studying predict exam performance. Multiple regression is an extension of simple linear regression with just one little change. Well, little is probably pushing it, but multiple regression is while simple regression predicts an outcome using one predictor variable. Multiple regression, a predictor variable is just the one here, right? Number of hours spent studying. Multiple regression, this is why it's cool, allows us to predict an outcome based on several predictor variables. So now we could say, change our research question to be something like, how do both hours of study and anxiety levels predict exam performance? Okay? So the key point here, if I can duck out the way, is that multiple regression shows the unique contribution of each predictor variable to the outcome variable, helping us understand which factor matters most. So let's unpack that with the following slide. So now we can add in, so we've got one predictor here, we can add in a second predictor here, anxiety levels. Now what the regression analysis will tell us is, okay, first of all, is there a relationship between the number of hours spent studying and exam performance, right? And it'll also tell us, is there a relationship between anxiety levels and exam performance, okay? And whether it's a positive or negative relationship between them. What it will also tell us is which of these predictor variables, number of hours spent studying or anxiety levels, was the strongest predictor as well, okay? Again, we'll go into this in more depth in a few weeks. So, again, a little bit of an activity. You can do this in your head. You can do this on paper or pen, whatever. But what we want you to do is think for a psychological research. It can be the same one as before. Would you use ANOVA to compare the groups or regression to explore relationships? So write down a research question and try and think to yourself, okay, which statistical test would I use for that? Okay, so identify a research question and try and think, okay, is it best to use, it can be as silly as my examples or as sensible as the other ones. And encourage you to justify the type of test that you're going to use, okay? Depends what you're interested in. Okay, so in the next section, we're going to look at choosing the right methods and the tools for your project as well.